Good morning all. Today we are discussing kernel electricity, a small topic in kernel electricity. There is drift velocity. See, we are considering a conductor. In this conductor, there are a lot of free electrons. These free electrons are in random motion. And they are having thermal velocities of the range of 10 raised to 5 to 10 raised to 6 meter per second, like that. Then this random velocity, when an external field is applied, external field is applied, field is in this direction. In the opposite direction of field, the electrons are drifting. The electrons are drifting in the opposite direction of electric field. Field is applied in like this, coming like this. Direction of current will be like this, but the direction of electrons is in the opposite direction. This velocity with which the electrons drifts is called drift velocity. For that, first of all, we will find out the force exerted here. F equals QE, where Q is the charge, E is the electric field applied. Here, the electrons are drifted in the opposite direction of electric field. So we can write F equals minus E. Then the electron is having a mass m and also an acceleration. We can write F equals ma. Then we can write both of are same. Ma equals minus E capital E. Then A equals minus E capital E by M. This is the acceleration of the electrons in a conductor. Now, see, we have got the acceleration. A equals minus E capital E by M. Now we are going to find out the velocity with which it is drifting. So by first equation of motion, V equals U plus AT. Now the drifting is starting from rest only. So we can write V equals AT. See, because U is equal to 0, since the drifting starts from 0 velocity. Here, time is the time taken for between two collisions. That time is taken as tau. So we can write V equals A tau, where tau is called relaxation time. Tau is called relaxation time. This relaxation time indicates the time between two successive collisions. Now, instead of A, we can substitute V equals minus E capital E by M. That is for acceleration. Then tau. This is the basic equation for drift velocity. Then we can write Vd is equal to minus E capital E by M into 2 based on the relaxation time. Next, we are going to derive a relation between drift velocity and current electricity. We are considering a conductor of length L Field is applied in this direction. The electrons are drifting in this direction. Let L be the length of the conductor. L is length of the conductor. Let A be the capital A be the area of conductor, area of cross section. Area of cross section. L is the length, A is the area. N is the number of electrons per unit volume. Unit volume. Now, we are going to find out the total charge. Q equals N is the number of electrons per unit volume. That you are going to multiply with volume of the conductor, that is AL into charge of electron. So we can write Q equals N A L E. N is the number of electrons per unit volume. A is the area of cross section. L is the length. E is the charge of electron. AL represents the volume of the conductor. Now time taken, T equals length divided by drift velocity. Length is divided by drift velocity. Then we can write I equals Q by T. We have defined electric current as charge per unit time. Q equals NALE divided by, instead of VD we can substitute, instead of time we can substitute L by VD. So I is equal to, VD comes up, NALE into VD by L. L and L cancels. You will get I equals NALE. This is the relation for LAVDE. L is cancelled. I is equal to NAVDE. L cancels. Here L and L cancels. VD is there, E is here, A is N. Now this is the relation to find out, or this is a relation relating electric current and drift velocity. Now we will go to the numerical part. See, we are going to estimate the drift velocity in a copper wire. Cross-sectional area is 10 raised to minus 7 meters squared. Current flowing is 1.5 ampere. Density of conduction electrons is 9 into 10 raised to 28. Charge on electron is 1.6 10 raised to minus 19. So here we can write A equals 10 raised to minus 7 meters squared. I equals 1.5 ampere. N equals 9 into 10 raised to 28 meter raised to minus 3. Charge of electron E equals 1.6 into 10 raised to minus 19. Now we know that I equals NAVDE. Now VD equals, VD means drift velocity. VD is equal to I divided by NAE. So instead of I, we can substitute 1.5 divided by N is 9 into 10 raised to 28. 9 into 10 raised to 28 into A is 10 raised to minus 7. into charge of electron is 1.6 into 10 raised to minus 19. Now, we will get Vd equals I is 1.5 divided by 9 into 1.6 is 14.4 into 10 raised to 28 minus 26. So 1.5 divided by 14.4 into 10 raised to minus 2. Final answer is 10.4 into 10 raised to minus 4 meter per second. And option is 1.